This is the Chapter 9, Day 2 lesson. So our teaching point is today I'm going to teach you how to calculate, or how to use an equation to calculate an unknown angle using the definitions of vertical angles and linear pairs. Again, so just like the prior day, I'm going to give you a bunch of definitions, but you're going to work with them throughout your book. So the first one that we're going to look at is the definition of a linear pair. So a linear pair are two adjacent angles that have non-common sides that form a line. Okay, so for example, if I have two lines that cross, I have four angles, 1, 2, 3, and 4. So I could say that angle 1 and angle 2 are a linear pair. So they're two adjacent angles, they're right next to each other, they share vertex and array that have non-common sides. So if I look at angle 1, here's the common side with 1 and 2. So the non-common sides, these two sides, form a line. So I could say angle 2 and angle 3, 2 and 3 together make a straight line. I could say angle 3 and angle 4, they make this straight line. And I could say angle 1 and angle 4. So I have four different linear pairs there. Okay, so maybe a question, and this is one that's often misunderstood, are linear pairs supplementary? Because they seem pretty similar. So if we look back to yesterday when we talked about supplementary, it's two angles who equal 180. Well, if two angles make a straight line, then two angles equal 180. So this is always the case. If you have a linear pair, it is supplementary. But let's see if we can do that the other way. Are supplementary angles linear pairs? That might be another question then. So are supplementary angles linear pairs? And in this case, they can be. For example, when I go back to my picture, this picture here, they're supplementary, two angles that add up to 180. They're two angles whose non-common side, this side and this side, make a straight line. But not here. These two, they don't even have a common side, so there's no non-common side. These aren't even pictures of angles. So they can be, but they don't have to be. So linear pairs are always supplementary. Supplementary angles are sometimes a linear pair. Okay, let's take the word adjacent. This one's always one that kids struggle with getting the definition. It's two angles that share a common side and vertex. Two angles that share a common side and vertex. So maybe I draw an angle like this, and I'm going to make it into two angles. These two angles, they share a common side. They both share this, and they share this vertex, so that means they're adjacent. A lot of kids want to tell me they're two angles that are next to each other. That's not quite specific enough. They have to be next to each other in a way that the side is shared and a vertex is shared. So maybe for that one, we could ask, well, are linear pairs adjacent? So let's connect to what we just did. Here, linear pairs, two angles. It actually says two adjacent angles. So right there it tells me that yes, always. Linear pairs would always be considered adjacent, but a linear pair is more specific because it's two adjacent angles that must equal 180 degrees. But maybe I ask this the other way. Are adjacent angles linear pairs? And that would be only if the adjacent angles equal 180 degrees. So in this case, these two are adjacent, but they don't equal 180 degrees. This side here and this side here do not make a straight line. So if they would, then they'd be considered adjacent and a linear pair. Okay, the last one is vertical angles. And this is two non-adjacent congruent angles congruent. I'm going to just kind of refresh our memory. Equal sign with the little squiggly above it. And they're formed by intersecting two non-adjacent congruent angles formed by intersecting lines, segments, or rays. Okay, so my example here, I'm going to have two intersecting lines. That makes four different angles here. The the vertical angles are they're non-adjacent, so they aren't two that share a side. And they're congruent, means they have the same angle measure. So angles 2 and angle 4, these two angles are vertical. Angle 1 and angle 3, so I'm going to put 2 marks there. Those two would be vertical. So if I told you the angle measure of 3, the angle measure of 1 would be the same. So possibly a question is, are they always equal measures? And that answer is yes. Adjacent or vertical angles always have the same measure. Okay, that's the end of the